Folks, we're not just dealing with fairyland speculation here. These are hard data by other groups too. Ourselves, yes, we corroborate each other. It can't be escaped. It has to be dealt with then. These data are out there, they're published. Anybody, I don't care whether you're Mormon, and Muslim, Catholic, Hindu, Jew, it doesn't matter. Scientific method cuts through all belief systems. Everybody can see these spheres. Atheist, doesn't matter. You can see the spheres, right? It doesn't matter whether you believe 9/11 was due to some rogue element in the government or what. It doesn't matter. You get your scanning electron microscope, as both of these groups have done and we have done. You look at these are prevalent. I'm sure there's a number of these in Boston. And you will see these spheres in the dust.
As I looked at the dust, I noticed some spheres. I was not expecting that at all, but some spheres that were just visible to the eye. And then I looked at those with electron microscope using elemental analysis called X-ray energy dispersive spectroscopy. And there we found that there was a lot of iron in these spheres. And I realized that a magnet then could pull these iron-rich spheres out of the dust so we could look at more of them. I remember Dr. Fair of BYU and I looked at this sample together.
I like to do this in a fume hood just because it's fairly uncluttered, and also who knows what's in this dust. Yeah, I'm not real impressed with this magnet, but I mean the looks of it. It happens to be a very strong magnet, and invariably you pick up all the other junk along with the magnetic materials. So that's why you have to sort of visually go through it with tweezers and inspect it and pick out and manually pick out the particles with tweezers. Yeah, I'm not real impressed with this magnet, but I mean the looks of it. It happens to be a very strong magnet, and invariably you pick up all the other junk along with the magnetic materials. So that's why you have to sort of visually go through it with tweezers and inspect it and pick out and manually pick out the particles with tweezers.
It's sort of, looking for a needle in a haystack almost, because there's so much dust.
Billions and billions of these previously molten iron microspheres. Oh, wait a minute. Scientific method's been around for 100 years or so. What are they doing there? How did they get molten? How did they get iron? And how did they get spherical? What could produce such an incredible array of microspheres?
Using a magnet, we're able to find very large numbers of these spheres. Some you can see with your naked eye, and more you can see with the optical microscope, and then many, many more you can see with the electron microscope. And many of these are aluminum and iron together in the sphere, a very unusual combination.
Now here's the new discovery, the question I want to pose today. Could we find unreacted thermite in the World Trade Center dust? We see the residue. This is the smoking gun already, but can we find the gun, I guess you'd say? The unreacted thermite. Ta-da! Many red chips I found in the World Trade Center dust. About last June, I started noticing these. They're attracted by a magnet. A thought came, well, maybe it's just paint. There's all over these little red chips. They're like eggshell chips. You know, you scrunch up an eggshell, and you get about that thickness, roughly speaking. These are quite tough, though. They're strong. And now these are bilayered. This only shows one side, the red side. The other side is a dull gray. Red is the color of iron rust, iron oxide. One of the oxides, Fe2O3. It already suggests something to you. They're attracted by a magnet, suggests iron as well.
I noticed there's also another type of particle in there, and this is what I call a red-gray chip. I started looking at the chips because they were distinctive, red on one side, gray on the other.
Okay, so I'm looking mostly for the red chips, because the red chips we find to be most interesting as far as the chemistry and also in the calorimeter. It's sort of, you know, looking for a needle in a haystack almost, because there's so much dust. This is kind of hard because you're going through this thing. You can't really tell where your tweezers are. And that's about as big as we're going to get. So in terms of millimeters, that the red chip is about it's close to a millimeter long, but it's maybe a 1/4 millimeter wide.
And now the chemical composition, are you ready, of these chips, the red side. I won't talk much about the gray side. It's harder to analyze using this method. But the red side has, I can just hardly wait to show you. Okay, here it is. These are red chips. The one is from the Liberty Apartment, McKinley. The other is from the Brooklyn Bridge sample. These also show, can you see it? It's very clear, iron. It's hard for me to point to it from here, but I think you can pick out now. Fe is iron, Si is silicon, Al is aluminum, K, potassium, very clearly, and of course, oxygen. It's the same signature as the spheres. It's the same signature as the commercial thermite. I've put them side by side so that you can look at this. Hopefully, as this is taped, you can, pause and make your comparisons. The same signature. Again, the amounts will vary from chip to chip and from sphere to sphere. And where you look on a chip, there are some variations. And certainly where you look on a sphere, there are some, from sphere to sphere anyway, there are variations. The spheres typically are small. A micron up to about 1,500 microns. 1.5 millimeters is the largest sphere that we've seen. So here's a comparison now from the Brooklyn Bridge sample, uncontaminated within 20 minutes of the collapse of the North Tower. Again, red chip on this side. Oh, wait a minute, I'm sorry. I've got to correct the title, sorry. The red chip is from the McKinley sample. The sphere, which is here, is from the Brooklyn Bridge sample. And so, but again, you see, from sample to sample, we see the same pattern. Fiok Alsi. Okay, now this is from, so I have to look at the title. I remember red dust, I called it back then. When were those data taken? June, yeah, June, you see, of this year. This is the first time I've discussed these red chips publicly. I think it's important to get this out. We have done some other tests. Oops. I want to mention, so one of the tests I did, so I took one of these red chips and had a friend scan. It's hard to get thermite to ignite. And I thought, how can we tell if this is thermite or not? It's not easy. It has the right chemical signature. Aluminum, iron, oxygen is what you need, and it's got some other goodies thrown in, silicon and potassium. And so typically, I put the K in parentheses, not all of these show much potassium, but anyway, that's the signature. And so a friend of mine has an oxyacetylene torch with a very fine tip. He uses it for repairing eyeglasses. And so I had him pass it over one of these red chips. It was just 1/32 of an inch on a side, approximately square, and it flamed, it flashed. As he passed over it. Now that's not itself a proof, but it's a strong indication, along with the chemical composition and the red color, which indicates iron oxide, that this is a form of thermite. I've provided red chip samples now to an independent laboratory for testing, with the question to them, do they agree, do they find that these red chips are a form of thermite? Technical term is aluminothermic. Independently, Justin Keough and his team, I know he's working with Richard Gage, is now also looking at the World Trade Center dust spheres and red chips also. Excited to say. Richard called up Justin last night. I talked to him on the phone. Oh yeah, we saw some of that red stuff, you know. He said, we tried it in a Raman spectrograph system analysis. And he said, we hit it with a laser. Now this stuff is behaving like thermite, folks. Again, I'm inviting scientific scrutiny of these red chips. I believe this is the last nail in the coffin, so to speak. Thanks.